Hi, I'm Steve from Kiln.AI, and this is a demo of how you can build a RAG system in under 5 minutes. After we build it, I'm going to explain how RAG systems work and show you each step of the process and what's happening under the hood. And after that, we'll cover some more advanced topics, like building a RAG system with audio and video files, and how to optimize your RAG for optimal performance and quality using evals. Let's jump right in. First things first, what is a RAG? Well, in the simplest terms, a RAG is when an AI system looks up information to ensure its response is accurate. Let's look at a little example to show why that's needed. Inside the Kiln AI app, I've built a simple Kiln Assistant task which answers questions about what Kiln can do and how it does it. Now let's ask it a simple question and run the task. And great, the model GPT-4.1 Mini has given us an answer and explained that Kiln has some powerful shortcuts. There's only one little problem. These don't exist. The model has completely hallucinated a set of instructions. GPT-4.1 Mini didn't memorize all of Kiln's keyboard shortcuts and can't give you a perfect result all by itself, so it's just hallucinated out something here. Now, Kiln actually has excellent documentation, walking through all the different concepts of the system, including great docs on our keyboard shortcuts that outline every single keyboard shortcut in the app. Had the system been able to read our docs, it would be able to give you a precise and accurate answer. But it can't just go randomly read the internet, so we need to give it that capability. And to do that, we're going to create our RAG system. The first step of making a RAG system is to collect all of the documents you want to make searchable. I've downloaded all of Kiln's documents as PDFs, including the keyboard shortcuts document we just looked at. Next, back in the Kiln UI, we'll go to the Documents and Search tab, click Manage Documents, and add all of our PDFs. Great, all our documents are now available to Kiln. And now it's easy for us to create our own RAG based on those documents. In Kiln's UI, return to the Document and Search tab, click Manage Search Tools, and create a new search tool. If you're new to RAG, we suggest selecting one of our templates to start. We've curated a set of RAG templates with the latest and greatest models, and we keep this up to date as new models are released. Depending on your needs, you could select the best possible model if you don't care about costs. If you have thousands of documents, you may want to choose the cost-optimized model. And if you prefer privacy, you could do something like our all-local version, which runs completely on your machine using a llama. For this demo, I'll pick best quality. I just need to give my new RAG a name, type in a description of what it does, and select which documents I want to include. In this case, all of the knowledge-based documents. Then it's just one click to create our new RAG. And click Run to start processing all of our documents. And great, our processing is complete. Now let's go run our new RAG tool. Back in the Run tab, we'll type the same question as before. We'll select the same model, but this time we'll select our new knowledge-based search RAG tool as well. And we'll run it. Great, we've got an answer. And this time we can see that the results from our assistant actually perfectly match those from our documentation. We can actually look at the message trace and see that the AI assistant called the knowledge-based search tool with the query keyboard shortcuts and got back relevant chunks of documents from our documentation, giving exactly the information it needed to accurately answer the query. And that's all it takes to build a fully functional RAG system in Kiln AI. Let's try another query. And run it. Great, another accurate answer, and another case where we can see it's making a relevant call to the knowledge-based search tool, in this time with the query fine-tuning providers supported by Kiln. All right, so that was pretty cool. In under 5 minutes, we built a fully functioning, state-of-the-art RAG that's ready to be integrated into your application. Now let's go a little bit deeper and understand how it works. There are 5 steps to a typical RAG workflow. Let's walk through them one by one. First, with document extraction. Back on the example we showed earlier, it made a call to our knowledge-based search for the query keyboard shortcuts and returned a really nice textual description of the document from our knowledge base. However, you probably recall that document was a PDF, How did we go from this structured PDF to this textual description? We call that process document extraction, converting the files in the format you have them, like PDF, into text, which large language models can read and quickly process. And how do we do document extraction? Well, if this was last year, we'd probably use a library like Docling or Markdown. That's actually a bunch of code that knows how to read and parse PDF format and try to reassemble it into a textual description. But it's 2025, and over the last year, vision language models have gotten really, really good. Vision language models are large models that can take visual inputs like pages of a PDF or images or even videos and create a textual description from them. They've been around for a while, but in the last year their quality's gotten much better, and now they blow away traditional methods like OCR or libraries that understand PDF format. They have better spatial understanding, they have better understanding of tables, graphs, and images, and they're better at inferring meaning and structure from looking at a document. And a secondary benefit is that they handle a lot more types of data. Instead of one code path for images and another for PDFs, vision language models can often take many modalities. So they can have images, video, audio, PDFs, and more, all from one extraction model. Back in Kiln, let's set up a document extractor. We'll go back to the Docs and Search tab, click into Manage Search Tools. We'll create a new search tool. And this time, instead of selecting the template, we'll create a custom search tool from scratch. And we'll create a new extractor configuration. And there you can select a vision language model. We currently recommend using Gemini 2.5 Pro if you're okay with closed models, or if you want an open model, Qwen 3VL is currently the best option going. Next, pick the output format. We typically recommend Markdown over plain text, as the little bit of extra formatting can really help the model understand. And after that document extraction is run, we can go back to the document library, click into a document, and actually compare how different VLMs have extracted that document. And you can already see difference between the VLMs. Qwen is using the Markdown tag and is using emojis for bullet points. Well, Gemini has gone as far to actually look at the images and write a description of what each one contains. Now, some of you might ask, well, if VLMs can process images and documents, why not just use them instead of building a RAG? And the answer is speed and performance. Processing a document can cost a lot and take many seconds, and searching across hundreds could take a very, very long time. So instead, with a RAG, we pre-process all of your documents once, save their textual representations, and that allows us to very quickly and cheaply access them when we need to get information out of our RAG. All right, now that we've extracted our documents, let's go on to step 2, chunking. Chunking is simply the process of taking really large documents and splitting them into smaller pieces or chunks. And we do this for 2 reasons. The first reason is just to reduce the size of the text returned to the LLM. If you had a 1,000-page book, you wouldn't want to return that all just to get a small piece of information out of it, and you might overflow the context window of your LLM. The second reason is relevance. That 1,000-page book might cover 100 different topics. And if we only search at the book level, it's kind of hard to find the exact right piece of information we need. Whereas we split into a bunch of smaller topics, when we search, we're more likely to pull out exactly the relevant chunk that we're looking for. Back in the Kiln UI, you can actually see this. Some larger documents are being split into many chunks, which improves relevance and reduces the amount of text we're returning into your context window. And just like document extraction, you set chunking up when you create your RAG. So I'll select a new chunk configuration, and I've got a few options to choose from. Fixed window is the simplest, having a fixed number of tokens in each chunk, and some overlap so sentences aren't truncated or cut in half. A second option is semantic chunking, where Kiln will actually iterate through your document, create hundreds or thousands of embeddings, and attempt to chunk the document by topic, so that each chunk is a relevant, cohesive piece of the document, and not just arbitrarily truncated at certain lengths. All right, and after chunking comes embeddings. Now, embeddings are a fairly complicated technical concept, so we're just going to cover them at a really high level here. But if you want to learn more, I suggest going and doing some reading. The quick version is that embeddings are another type of AI model that can take text, in this case the chunks we just created, and create a semantic vector out of them. And by that, it's a numerical representation where similar concepts, semantically similar concepts, will appear near each other in space. So shipping and delivery times being near each other, contact and support, and refunds and billing. So how do we use that in RAG? Well, we can take a query from the user, run it through an embedding model, and put it into the same space, and find the most adjacent documents. those are likely going to be the documents with the most semantic relevance to what the user is asking for. So this is really kind of the backbone of how RAG systems work. Back in the Kiln UI, the third step of creating a RAG is selecting your embedding model, and you can select from a wide range of state-of-the-art embedding models and add them to your RAG. And after embeddings comes search indexing. Search indexing is how we actually look up the information we want to return back to the RAG. This comes in a few different forms. The first is vector search, where we use the embeddings we just talked about to find the nearest neighbors which are going to have the most semantic similarity to the user's query. The next is a classic text search, where you look up the exact words inside the query. You don't always need this, but it can be really helpful in some situations, like searching invoices for the name of a company. It might not have a lot of semantic meaning, but looking up the exact proper noun is probably going to be really powerful. And finally, hybrid combines two forms and is usually the form we recommend. Back in the Kiln UI, you can create a new search index just by picking your search index type, usually hybrid, and the number of results you want to return back. And finally, after search indexing comes re-ranking. This is an optional step, but where re-ranking evolves as yet another type of AI model, in this case one that runs on the results returned from your search index. It tries to find the best results, reorders them, and usually filters it down to a shorter, more relevant list. It's a way of getting a little bit extra relevance out of your system. It's optional, but it's a good optimization if you want to search through a lot of documents. And that's it. That's all the steps you need to build a RAG system from scratch, either the really easy way in under 5 minutes using a template, or getting into the nitty-gritty details with a custom configuration. And if you want to create your own RAG system, head on over to Kiln.tech, where you can download the Kiln app completely free and build your own RAG in under 5 minutes. And after you create your RAG, everyone asks the obvious next question: how do I optimize it to find the best combination of document extractors and chunking and indexing that returns the best results from my dataset? Kiln makes the optimization process easy too, by allowing you to create a RAG evaluator that can compare different RAG configs and find out which works best on your dataset. If you want to learn how to do that, head on over to our blog where we've got a write-up, or subscribe to the channel for a future video on the topic. And speaking of other videos, if you want to learn other skills around building AI systems like tools in MCP or building your own agent system, check out our other videos or our docs at docs.kiln.tech. Thanks for watching.